All right, so let's look at proportion word problems. We've been working with proportions a lot. We're going to look at some different scenarios where it's not specifically unit rates and also a different strategy than other than using just a proportion. So we are going to go straight into the problems because we already kind of know how to set up a proportion. So problem number 1, if it takes Mike 18 minutes to read 4 pages in a book, how long would it take him to read 10 pages? Remember, I am showing this using a proportion. You can certainly use different routes when you're working on the practice independently if you choose a different route that works for you and you still get the right answer. So, looking at the information given to us, I'm circling the numbers given in the problem. Then I'm going to label the units. So 18 minutes, 4 pages. So our 2 units we are comparing are minutes and pages. So 18 is with minutes, we're going to put that on top. 4 is with pages, so we'll put that on the bottom. Then we're looking at that third number that's given to us, the number 10. 10 says 10 pages, so we need to match it up with pages, which is on the bottom, which means we're solving for the number minutes, which makes sense because it says how long. It's asking what the time is. So now we are going to solve. I'm looking at my proportion. I'm looking at the 2 diagonals in the problem. I find the diagonal that has 2 numbers in it. That's what I'm going to multiply. So 18 and 10 is the diagonal that has 2 numbers. So I'm going to multiply 18 times 10, which is 180. Then we divide by the number that's in the same diagonal as the variable, so that's 4. And we get 45. Then I gotta go back, figure out what units we're talking about. X is on top, which is with minutes, so 45 minutes. All right, number 2. To make yellow icing, you mix 2 cups of white icing with 9 drops of yellow food coloring. How much yellow food coloring should you mix with 5 cups of white icing to get the same shade? So we're going to set up our blank proportion. Even though it's not set up as a blank one for us, we can make our own. I'm going to look at the numbers that are given to me in the problem, 2, 9, and 5, and use that to figure out the units. So it says 2 cups of white icing, so I'm just going to say cups, and 9 drops of yellow food coloring, so I'm just going to say drops. You could do icing versus food coloring, something to show the difference. So 2 is with cups, so that's going to go on the top with cups. 9 is with drops, so that's going to go on the bottom, so it matches with drops. Our third number that's given to us in the problem says 5 cups of white icing. So we put cups of white icing on the top, so we have to put 5 on top, which means we are solving for the drops, which makes sense because it says how much yellow food coloring, which means how many drops do we need. Now we can solve our proportion. Looking at our 2 diagonals, we find the diagonal that has 2 numbers in it. This diagonal has the 2 numbers, 9 and 5. So those are the 2 that we are going to multiply together. So 9 times 5 is 45. And then we divide by the number that's in the same diagonal as the variable. So I'm dividing by 2, which gives me 22.5 or 22 and a half. Our X was on the bottom, which matches with the drops. So 25 and a half drops of food coloring. Okay, number 3. The Millers drove 105 miles on 4 gallons of gas. At this rate, how many miles can they drive on 6 gallons of gas? So I'm going to circle my numbers, 105, 4, and 6. And I'm going to set up my blank proportion. Finding my units, look by the numbers. 105 miles 4 gallons. So the 105 goes with miles, which we put on top. The 4 goes with gallons, which we put on the bottom. At this rate, how many miles can they drive on 6 gallons of gas? So it needs to match with gallons, which we put on the bottom. And that means we are solving for miles on the top, which makes sense. It says how many miles. Now let's look at our 2 diagonals. We need to find the diagonal that has 2 numbers in it. So we're going to multiply 105 times 6 because that's the diagonal that has 2 numbers in it. So 105 times 6 is 630. And then we divide by the number that's on the same diagonal as the variable. So we divide by 4. And when we do that, we get 157.5. Our x was on top, which coincides with miles. So we were solving for the miles. So these were all pretty similar problems. You are given a part-to-part relationship. We're using a proportion to solve. Now let's look at if we're given a part to part, but then might have to solve for the whole. So Diane took a math test last week. The ratio of the number of problems Diane got incorrect to the number of problems she got correct was 2 to 7. So we're going to use this ratio of 2 to 7. If Diane missed 6 questions, how many did she get correct? So what we want to practice here is using a different method, a different problem-solving method. So we're going to use what we call a tape diagram. After we're through with the notes, you don't have to use a tape diagram to solve. I'm just showing you here an alternative route that you can use if you would like. So we're comparing the ones she got incorrect to the ones she got correct. It was a 2 to 7 ratio. So we're going to make kind of boxes to represent. 2 boxes for the 2 part of the ratio, 2, 7 boxes. That's representing our 2 to 7 ratio. It said Diane missed 6 questions, so that means that's how many she got incorrect. So this right here is representing 6. So if we have 2 boxes that equals 6, that means each box has to represent 3. So if each box represents 3, I can transfer that down here. 3, 6, 9, 12, 15, 18, 21. So what that tells me is the number that she got correct was 21. So an alternate way to solve. Let's look at part B. If the test had 36 questions on it, how many problems did she get correct? So, same thing, let's set up our tape diagram. We're comparing 2 boxes for incorrect to 7 for correct. But the difference is that we are saying that this whole entire thing we have to look at because the test had 36 questions. So the incorrect plus the correct equals 36. So we have this total of 36 that we need to divide by 9 boxes because there's 1, 2, 3, 4, 5, 6, 7, 8, 9 boxes, which gives us 4 for each box. So we just want to know how many she got correct. I'm going to plug 4 into each box. So 4, 8, 12, 16, 20, 24, 28. So that tells us she got 28 correct. All right, these last 2, we are just going to go back to solving with a proportion to show you, especially with that ratio comparison, how you can use a proportion for it. So Madeline had a class ratio of 5 to 4 boys to girls in her classroom. If there were 27 kids in her class, how many girls were there? So first off, we are comparing boys to girls, but then it gives us a total for the class. So what I'm going to do is if I have a ratio of 5 to 4, that means a total of 9. So what we're really comparing here is the girls to the total. So it was 5 to 4 boys to girls. So the 4 matches with the girls. So I'm going to put 4 on top with a total of 9 because we added those two together to get 9. And then there were 27 kids in the class, so that's the total. We want to know how many girls. We are solving for the number of girls. Now, I can look at my diagonals, find the diagonal that has 2 numbers in it. So we've got 4 and 27, which equals 108. I divide it by the number that's in the same diagonal as the variable, so I'm dividing by 9, and I get 12. So there are 12 girls. All right, last one. Lily had a ratio of 6 to 2 rock and country songs on her MP3 player. If Lily had 36 rock songs, how many country songs did she have? So we're not comparing a total here, so we can just do this regularly. We're comparing rock to country. So rock to country ratio is 6 to 2. This 36 matches with rock, so we put that on top to match with rock. We're solving for how many country. Let's look at our diagonals. And then let's solve. The diagonal that has 2 numbers is this one right here. So we're going to do 2 times 36, which is 72. Divide by the number that's in the same diagonal as the variable. So divide by 6, and we get 12. So 12 country songs. And that's it. So when you're working on the practice, you can decide for yourself. Do you want to try to use a tape diagram, or do you like using a proportion? Maybe you have a different route that works for you as long as you are showing your work.